In this video, we will go over graph transformations. We're going to look at different notations that would tell us whether the graph is moving left, right, up, down, stretched horizontally, stretched vertically, flipping horizontally, or flipping vertically. So let's take a look at some of these notations. When we see the original function f of x, and it is added to a number, whether it's negative or positive, we can have a vertical shift. So for example, we have f of x equals x squared, and we have the function x squared, and there's 3 added to the x squared, then we see it is a shift up 3 units. And if we see x squared minus 2, the graph of x squared will be shift down 2 units. So if k is bigger than 0, you're going to see an upward shift. K is less than 0, then you're going to see a downward shift. Horizontal shift. If we see f of x minus h, if the input is changed to x minus a number, then you're going to see a vertical shift, the horizontal shift. So for example, the input instead of being x is going to be x minus 3 squared. That's going to tell us that the graph is shifted to the right 3 units. And if we see x minus a negative 2 in parentheses squared, that means the graph is shifted to the left 2 units. And notice that negative 2 is an indication that's going to move to the left. But overall, if we were to simplify this part, that's going to be x plus 2. So sometimes we students often see a x plus 2 or x plus 3. They would assume it's going to move it to the right, but we always have to change it back to the x minus h form. So if we were to change this into x minus, it's going to be in this form where that h is actually a negative 2, so we moved it to the left. Okay, so if h is greater than 0, move it to the right. If h is less than 0, move it to the left. All right. Reflection. If you have a negative in front of f of x, remember that f of x it's a y value. So negative in front of the y value, that would make that y value the opposite. So it's the flip over, like it's going to be a vertical shift, vertical flip. So here's the x-axis. Here's a point up here where the y value is positive. It's going to flip over the x-axis, flip vertically to this location where the y value is the opposite of the y value at this point. So here we call this a vertical flip, or flip over the x-axis. If we have a negative inside the x value, that makes the input opposite, the x value the opposite. Opposite x values are located horizontally. So this will give us a horizontal flip, which is a flip over or reflection over the y-axis. So for example, if we have g of x equals a negative x squared, then that's going to be a flip over the y-axis. If we have g of x equals a negative and then x squared, is going to be a flip over the x-axis. Now we have a combination of negative f of negative x. That's a combination of horizontal and vertical flip or reflection. Next, let's take a look at what happens when we have a number multiplied to f of x. For example, we have, let's say, 3 times x squared. What that 3 does, it's going to give us a stretch vertically. So if a is bigger than, the absolute value of a is bigger than 1, then we're going to have a vertical stretch. For example, a is equal to 3, a is equal to negative 3. If we have the absolute value of a is less than 1, then we have a vertical shrink. Or compression. So for example, we have negative 1/2 x squared. That would give us a vertical compression and also reflection. Vertical stretch, if we have, again, 3x squared. Next, horizontal stretch or shrink. Inside the input b times x, b would tell us whether it's going to be a stretch or a shrink. Shrink, compress. Shrink is the same thing as compression. All right, so if b is negative, we know from there, if there's a negative inside the input, it's a horizontal flip or reflection. Okay, now if the absolute value of b is less than 1, so for example, 0.3, 0.2, you're going to end up having a horizontal stretch, which is a bit opposite. It's opposite from what you would expect over here. If the absolute value of b is greater than 1, then we're going to have a horizontal compression or shrink. Now we can also have a combination of this. So g of x equals a times f, and the input is b times x minus h, and then plus k on the outside. We can also always have a combination of all these. All right, let's take a look at an example here. We're given the graph of f of x below. Graph the following transformation. F of x minus 3, so this one tells us that everything is being moved down 3. So what I'm going to do is I'm going to take some of these key points here, and then I'm going to move everything down. So when we move everything down, I'm going to label these points negative 3, comma, negative 5, negative 2, comma, negative 3, 1, comma, negative 3, 3, comma, 1, 5, comma, negative 3. Going to take all these points and move down. So if I were to take this point and move down 3 units, 1, 2, 3, then the y value here is going to be subtracted by 3, which would give us a negative 8. So let's write that down here. That negative 3, comma, negative 5 is going to turn into a negative 3, comma, negative 8, because you're subtracting the y value by 3 units. Okay. So negative 3, negative 8, 6, 7, 8. And then we have the point, the second one, negative 2, comma, negative 3. Subtract the y value by 3, so negative 3 minus 3 is going to be negative 6. So we have the point negative 2, negative 6. And I'm going to pick the next point, 1, comma, negative 3. We're going to move that point down 1. The y value is going to move down 3 units, so that's going to be negative 6. 1, negative 6. Next we have 1, negative 3. Oh wait, we did that already. We have the point 3, comma, 1 right here. Move down 3 units, so the y value, it's being moved down 3 units. 1 minus 3 is going to be a negative 2. 3, negative 2. And then we have the point 3, comma, 1. Oh wait, we did that. 3, comma, 1, 5, negative 3. And we're going to move that down, so the y value is going to be moved down 3 units. Negative 3 minus 3, that's a negative 6. 5, negative 6. All right, so now we see the general shape. So I'm going to just copy that. So like that. This, and then the curvy part right there. All right. So this is what the graph of f of x minus 3 looks like. Now here we have part B, f of x plus 2. X plus 2 is within the parenthesis. So this means that we're Remember x plus 2? We have to change this into f of x minus a negative 2, so that's in the form of x minus h instead of x plus h. Okay, now this indicates that negative 2 indicates that it's going to be moving to the left 2 units. All right, so when we move left, that changes the x values, right? So at this point, we're going to move to the left 2 units. So the x value would be, we will subtract the x value by 2. Okay. So I'm going to indicate the point. So x value minus 2. The first point, negative 3 comma negative 5. Moving it to the left 2 units. Negative 3 minus 2 is a negative 5, and then the y value stays the same. Negative 5, negative 5. Then the next point, negative 2 comma negative 3. Subtract the negative 2 by 2. Negative 2 minus 2 is a negative 4, and then the y value stays the same. Negative 4, negative 3. Next, we have the point 1, negative 3. 1 minus 2 is going to be a negative 1, and then the negative 3 stays the same. The next one, 3 comma 1. 3 minus 2 is going to be 1, and the y value stays the same. 5, negative 3. 5 minus 2 is 3. Y value stays the same. Then let's plot these points. Negative 1, negative 3, 1, 1, and 3, negative 3. Then we're just going to connect these dots. All right. Next, we have part C, a negative in front of f of x. So that means it's a vertical reflection or flip. So that means the y value is going to be the opposite. So the point opposite y value. So the point negative 3 comma negative 5 is going to become negative 3. Opposite of negative 5 is going to be a positive 5. Negative 2 comma negative 3. Opposite of negative 3 is going to be positive 5. 1 comma negative 3. Opposite of negative 3 is going to be positive 3. And the next point, 3 comma 1. Opposite of positive 1 is going to be a negative 1. And lastly, 5. Negative 3, opposite of negative 3 is going to be positive 3. Then we plot these points, negative 3, positive 5, negative 2, positive 3, 1, 3, 3, negative 1, 5, 3, and then connect the points. So notice if you look at this, it looks like it's the graph has been flipped over vertically. Last one of this type, we have 2 times f of x. So the 2 is outside f of x. Remember that f of x is the same thing as the y value, so we're taking the 2 and we're going to multiply that to the y value. So y value times 2. All right, so these points, negative 3, negative 5, we're going to multiply the y value by 2, so we end up with a negative 3 comma negative 10. The point negative 2 comma negative 3, multiply the y value by 2. Negative 3 times 2 is negative 6. Next point, 1 comma negative 3. The y value times 2, that's a negative 6. Next point, 3 comma 1, y value times 2. 1 times 2 is 2. Last point, 5, negative 3. Negative 3 times 2 is going to give us negative 6. Then now let's plot these points. 3, negative 10, 6, 7, 8, 9, 10, somewhere down here. And then negative 2 comma 6, negative 6, and then next, let me count this one again. So let's see, 6, 7, 8, 9, 10. So it's probably down here. Let's pop the point -3, -10 again. And then we have -2, -6, 1, 6, and 1, -6, 3, 3, 2, 5, -6. And then just connect these points. So notice that vertically it's kind of stretched out. All right, so this is how we take a graph of the original function and perform some of the transformation based on the formula that's given to us.